in this problem, we want to make the compound above from acetylene. So let's see a few things in the structure. So here we have 2 carbons. Here we have 1, 2, 3, and 4 carbons. So we need to add carbons to the chain. They're also opposite to each other. And we also need to add 2 OHs, and they're opposite to each other. So I'm going to do a Newman projection of that, so that you see that this compound is actually a meso compound. So if we look at that from, say that my eye is sitting here, I'm going to draw the Newman of that compound, and it is the following. So the carbon in the front is this. So OH is here. So H is to your right-hand side. CH3 is here. And then from this point of view, this carbon is in the back, and you have an OH, right? And then you have to your right a CH3 and an H. And as you can see, oh, that's an H. CH3 opposite to each other, and which is opposite to each other, that's me. So you can see that if you did 180 rotation over here, you will get the one that has everything eclipsed. So here you can see a center of inversion. But if it's easier for you, you can draw the other rotamer. So keeping the one in the front the same, we can put the other OH in the back. And when we do that, I forgot to write that this is a CH3. And when you do that, you rotate that over here, then the metal is going to be also another metal group eclipsing 2 metals, and here 2 H's. So that is a meso compound. So things that we need to realize when we are designing the synthesis. Then I see that I need to add 2 more carbons to the chain. So the best way to do that is then using the acid-base property of the hydrogen here. We have 2. So in one reaction, we can do a sequence of reactions in which we add, say, sodium amide, and then we're forming the anion here. And in step 2, we will add metal iodide, for example. So we will do a methylation. That's an alkylation, we also call that. We're adding alkyl groups to the chain. So now I have already 3 carbons. If I need to add 1 more, we're going to repeat the process. So I'm going to draw that over here. Again, we're going to be using sodium amide. And this time I'm going to draw it directly. It's the same process, is an alkylation, and I will have now 2-butyne. Now, next thing that I need to know is the 2 CH3 need to be opposite to each other. So we can do a hydrogenation, partial hydrogenation, but the one that keeps the trans configuration of the alkenes. So here what we're going to do is use sodium and ammonia to get the trans alkene here. So once I have the trans alkene, we have some steps done. Now to get the OH, OHs opposite to each other, what we can do is an epoxidation. We can do a diol synthesis by using peroxides. So if we use 1 peroxy acid, say that we use peroxy benzoic acid. And in that, we will do an epoxidation. So let's do draw the structure. So we know that the metals are already like that. If we do an epoxidation, say that I have, that's my epoxide. And under acidic conditions, I will have that. And then you will have the attack by water, the nucleophilic attack, to open that epoxide. So we will do, and remember that whenever we form those intermediates with that structure, the attack is opposite to that cycle there. So here your nucleophile is going to be water, and it is opening on side. So that way I will get the two OHs opposite to each other. So we will have, say, I have now the metals. I will have one OH here, and the other OH, I will have it too, the other side. So say that I have that, and here I have H and H. So in this is our compound, the two metals are opposite to each other and the two H's are opposite to each other. So this will recap what we do here. First is we need to see from how many carbons we have in the starting molecule. We have acetylene, 2 carbons, we need to add 2 more. So what we did is 2 consecutive alkylations. So acid-base proton transfer reaction create the anion, SN2, methylation, and then we'll repeat that, and now we have 2-butene. Then we do the partial hydrogenation to get the transalkene with sodium and ammonia, and then we create an epoxide, and then we do the nucleophilic attack to have the transdiol, and that way we get the meso compound that we want there, is our target molecule.